Welcome to my channel. Thanks for watching my channel. In this lecture, we are going to discuss about the ratio method. We are studying time and distance. Please look over my previous lecture for a better understanding. We have discussed about the time and distance in the previous lecture too. Please look over those lectures. And in this lecture, we are going to discuss about the ratio method. So, in the ratio method, suppose we have a formula here. Speed equal to distance by time. Speed equal to distance by time. Suppose if we have two persons, let us name A and B. Suppose their speed are in the ratio x is to y. Their speeds are ratio in the ratio x is to y. So if suppose here the distance is constant, so distance d is constant. So if the distance d is constant, if it is constant, so automatically speed is inversely proportional to the time. That is, if the distance is constant, then if the speed ratio is in the ratio x is to y, then the time ratio will be in the ratio y is to x. It is the most important problem, and we can solve many problems by using this method. I will show clearly with the example when we go to the example. Just to remember to the part here, that is, if d is constant, speed is inversely proportional to the time. So we are not going to care about the distance. The distance is same. So if the speed is ratio in the ratio x is to y, that the time is will be in the ratio y is to x. That is in the reverse ratio. It is one of the formula. So this is one formula in ratio method. That is, what is the formula? When d is constant, suppose the distance is constant, then if the speed ratio is in the ratio x is to y, then automatically you have to take the time, the inverse ratio. That is the time ratio, compulsory it will be in the ratio y is to x. So this you have to remember, right? So let's move to the another formula. So we can derive another formula here. See here, speed equal to distance by time. If suppose we say that time is constant. So if time is constant, automatically this time is constant, then speed is directly proportional to the distance. Yes, that is, if suppose we take two persons A and B, if suppose their speed ratio are in the ratio x is to y, then the distance ratio will also be in the ratio x is to y. So what ratio the speed is going to take? The same ratio the distance is going to take, because speed is directly proportional to the d. Whereas in this case, speed is inversely proportional to 1 by t. So here it is inversely proportional, whereas here speed is directly proportional to the distance. Why? Here the time is constant. When the time is constant, speed is equal to directly proportional to the distance. That is, the speed ratio is in the ratio x is to y, then the distance ratio is also going to be in the ratio x is to y, right? So this formula we should take directly when we deal with the problem. That is, if we have given the time is constant when we compare with the two different peoples, and if you have given the speed ratio, automatically you have to take the distance ratio same as the speed ratio, right? Whereas suppose if you have given the distance is constant, so if we have given the speed ratio, automatically we have to take the time ratio as the inverse. That is, if it is x is to y, we have to take y is to x. We can also derive another formula, another case. That is, in the previous day we have taken the distance constant, and also we have taken the time constant. There is called be another situation that speed can be constant. That is, this can be constant, that speed doesn't change. That is, if you compare two persons A and B, their speed is constant. The two persons have the same speed. If they have the same speed, so if we have given the distance ratio as x is to y, distance ratio is given as the x is to y, then the time ratio will also going to be in the ratio x is to y, because distance is directly proportional to the time, right? So these things we have to remember. So in the ratio method, so we have the three cases. One case is when the d is constant. So when the d is constant, the speed is inversely proportional to time. This is the one case. When the time is constant, the speed is directly proportional to the distance. This is another case. And when the speed is constant, the distance is directly proportional to the time. So we have to take the same ratio as the distance. So these three formulas are important while solving for the ratio method. Let us go to the problems and I will show how to solve the problems by using the ratio method. So here is our first problem. In covering a certain distance, the speed of A and B are in the ratio 3:4. So we have given two, that is A and B. The ratio of the speed is in the ratio 3:4. So the speed ratio is in the ratio 3:4, right? A takes 30 minutes more than B to reach the destination. The time taken by A to reach the destination is, right? So here the distance is constant. That is, the both people are traveling to the for the same distance, right? So we have given the speed. So automatically, what is the ratio of the time? It is the inverse ratio. We already studied with our formula that if the distance d is constant, if the speed ratio is in the ratio x is to y, then the time ratio is going to be in the ratio y is to x. So what is the time ratio? It is 4:3, right? So what here we have given, A takes 30 minutes more than B to reach the destination, right? So A is taking 30 minutes more than B, but what is in the ratio? What is the difference? We have only 1 unit difference. So what is the 1 unit? Now what we have said in the question, A takes 30 minutes more than B. That means what? This 1 unit is equal to what? 30 minutes, right? This 1 unit is going to be 30 minutes. So what you have asked, the time taken by A to reach the destination. We know what is 1 unit, it is 30 minutes. Then what is the time A is going to take? He is going to take 4 into 30 minutes. So what is 4 into 30 minutes? It is 120 minutes. What does it mean? It is 2 hours, right? So like this we can easily solve by using the ratio method, right? I think you have understood. I want to say it once again, right? See here, if the speed ratio is in the ratio 3:4, the time ratio is going to be in the ratio 4:3. The depending on only one condition, the distance is constant. Both are traveling to the same distance. Then only we can take this formula, right? We have seen the difference is 30 minutes between A and B. So automatically what is we have 1 unit difference between A and B. So automatically 1 unit stands for 30 minutes. Then we have asked for the time taken by the A. It is nothing but 4 into 30 minutes. It is 120 minutes. It is 2 hours. Let us move to the next problem. The speed of A and B are in the ratio 3:4. So we have given the speed of A and B. So what it is? It is speed is in the ratio 3:4, right? Now A takes 20 minutes more than B to reach a destination. In what time does A reach the destination? So here also the distance is constant. That is, they are moving to the same distance. Same distance is there. So automatically, what is the ratio of the time? It will be 4:3, right? Now here given that A takes 20 minutes more than B, but if we observe the ratio difference, it is 1 unit. Means what is it? What you have said, A take 20 minutes more than B, means what is the unit? 1 unit is equal to what? 20 minutes. So if the 1 unit is going to be 20 minutes, then what time does A reach the destination? It is nothing but 4 into 20 minutes. So what time is going to take? 80 minutes. But in the option, if you see the options are in the hours. So we have to convert this into the hours. 80 by 60 hour. So if we do the 80 by 60 hour, it will be, right? So 3, it is 4 by 3. So if we divide 4 by 3, right? So 3 1 is 3, that is 1 by 3 hour. 1 by 3 hour. So this is the answer, right? So if you understood the ratio method, it is very easy to solve, right? Let us move to the next problem. Our next problem is the speed of two trains are in the ratio 6:7. So we have given the speed ratio as what? 6:7. Now if the second train runs 364 kilometer in 4 hours, then the speed of first train is. So here you have given that it runs what? 364 kilometers. So what is the distance? Distance is 364 kilometer, right? So both are running to the same distance, right? So but what here I have seen, this particular train, that is the, we have two trains, A train and B train. This B train runs to the destination in 4 hours, right? So if the distance is constant, automatically, that is, both are moving to the same distance, so distance is constant. If the distance is constant, if the speed ratio is 60:7, then the, what is the time ratio? It will be 7:6, because speed is inversely proportional to the time. So 7:6. But we have already given that B, what time it is going to take? It is going to take 4 hours. So if it is going to take 4 hours, automatically we have to calculate here what is the value of 1 unit. So 1 unit, what is the value of 1 unit? It is, if we convert it to the minutes, that is 4 into 6 is 240 by 6. 240 by 6, we are going to get 640 minutes. So 1 unit is equal to what? 40 minutes. So it is going to take 6 into 40 minutes. Then it is going to time A. What is the time A is going to take? It is going to take 7 into 40 minutes. Right? I think you have understood. I want to clarify it once again. See here. Here we have given that the distance is 364 kilometers. Right? And we are given the speed ratio. That is what? 6:7. So automatically we know that when they are traveling for the same distance, that is, the distance is constant, automatically the speed ratio is 6:7, then the time ratio will be 7:6, right? But, and also here what is the given in the question is given that B is going to take 4 hours to complete this distance. So if B, that is 6 unit, is going to be equal to the 4 hours. So we are going to calculate what is the value of 1 unit. So 1 unit, we have to, if you want to calculate, what we are going to do, we are going to convert it to the minutes. 4 into 60 minutes, that is 240 minutes by 6. If we divide it, we are going to get the value of 1 unit, that is the 40 minutes. Then if we get the value of 1 unit, it is 6. Then what is the value of A? It is 7. So we have, what we are going to do, we are going to do 7 into 40 minutes. So if we do the 7 into 40 minutes, we are going to get 280 minutes. 280 minutes. So we know the time of A and we know the distance. So it is easily we can find the speed of it. But what is the value of the, what is the unit of this time? Minutes. So we have to convert it what? To the hours. That is, we have to divide it by 60. 280 by 60. So if we do is, it is 14, it is 3. 14 by 3. Now we can easily calculate speed of A is equal to distance. What is the distance? 364 kilometer by, what is the time? It is 14 by 3. So by 3 is going to go to the top, right? So 14. So if we 7 2 ja 14 and 7 5 ja 35 and 7 2 ja 14, 2. If you divide more, 2 26. If you do 26 into 3, 6 3 ja 18, 3 2 6, 78. 78 kilometer per hour. So it is the answer, right? So let us move to the next problem. Let us move to our next problem. 3 cars travel distance in the ratio 1:2:3. So what is the ratio we have given? So what is the, it is the distance ratio. So the distance ratio is 1:2:3, right? So, and also he have given the time ratio. The ratio of time is 3:2:1. 3:2:1. Then the ratio of speed is, so he have asked us to calculate the ratio of speed. So what is the formula for speed? Speed equal to distance by time. We have given the distance ratio and we have given the time ratio. Then what is it? We can easily find the speed ratio. That is, here the speed ratio is going to be 1/3, 2/2 is to 3/1, right? So we have asked for 3 persons A, B, C. The distance ratio is 1:2:3 and the time ratio is 3:2:1. We know that speed formula is distance by time. So automatically if we have given the distance and time, we are going to divide it 1/3, 2/2 and 3/1. So 2/2 it's 1. So automatically, so what it happens, it is 1/3 is to 1:3. So 1 is to 3 is to 9. It is the ratio of speed. That is, we have multiplied this 3 into 1, 3 into 3, right? That is 1 is to 3 is to 9. So this is the answer for our problem, right? So let us move to our next problem. Our next problem is, a certain distance is covered by a cyclist at a certain speed, right? If a jogger covers half the distance in double the time. So here what he have given, there is a certain distance. Let us suppose the distance as d, right? A certain distance is covered by a cyclist at a certain speed. Let us take that we have a cyclist SC. I am going to represent by SC. So if the cyclist have completed this particular distance with a certain speed, right? Now if we have a jogger, let us suppose it by the SJ, right? If a jogger covers the half the distance, so what he have done, the speed is nothing but distance by for some time. Suppose we have taken the time t, so we are going to take speed of this particular cyclist is distance by time. Then what is I saying, that if jogger covers half the distance, in double the time, so if jogger is going to cover how much distance? He is going to cover d by 2 distance. And what is the time he is going to take? He is going to take double time, that is 2t, right? Then the ratio of the speed of jogger to the cyclist is, so he asks the ratio of the speed of jogger is to cyclist, right? If we solve this thing, d by 2 is d by 4t, right? That is, if we see the cyclist is going to take the d by 4t, and whereas jogger is going to take d by 4t, whereas the cyclist is going to take d by t. So dt we can cancel. So what is it is 1 by 4 is to 1. That is 1 is to 4. So 1 is to 4 is our answer, right? So let us move to the next problem. So next problem is, a train starts from A at 7 a.m. towards B. So we have given that a train is going to start from A, that is towards B. The train is going to start at what? At 7 a.m. right? Towards B with speed of 50 km per hour. So what is the speed? 50 km per hour. Another train starts from B at 8 a.m. So it is going to start at 8 a.m. with speed of 60 km per hour. 60 km per hour towards A. So it is going to travel this side, and this train is going to travel this side, right? So both of them meet at 10 a.m. at C. So both are going to meet at C point. They are going to meet at time 10 a.m. right? The ratio of distance AC is to BC is, so he wants this distance, right? So he wants this distance. What is the distance, right? So we want the distance AC is to BC. Now see here, this train have started at what time? 7 a.m. So it have met B at 10 a.m. So this 3 hours, what is the duration here? 3 hours. 3 hours it have traveled with the speed what? 50 km per hour. So what is the distance covered here? It have traveled the distance for 50 km per hour for 3 hours. So we know the distance equal to speed into time. So if we have distance equal to speed into time, automatically we know the speed of, what is the speed of A? It is 50, and it have traveled from 7 a.m. to 10 a.m. That is what? 3 hours. So 50 into 3, what distance it have traveled? 150 kilometers. 150 kilometers. So what is this 150 kilometers? It is what? D1. It is what? D1, right? Now in the same case here also, it has started at 8 a.m. and it have traveled for 2 hours, that is from 10 up to 10 a.m. That is what? How many hours? 2 hours. So 2 hours it have traveled with what speed? 60. So what is D2? It is S into T. What is the speed? It is 60, and what is the time? It is 2. That is 120 kilometers. So automatically AC is to BC is what? 150 is to 120. AC is to BC is equal to 150 is to 120. So 0 0 3 5 ja, 3 4 ja. So it is what 5 is to 4, right? So if we see the problem look a lot complicated, but if we solve, it is very easy. We have to understand the point. So this is the ratio method, right? Let us move to the next problem. Again, we are, as we proceed to with the different problems, we are observing the different approaches and different kinds of problem which I have asked in the examinations, right? So these are all the questions what I have taken. These are the repetition questions in the many of the bank and SSC and RRB sectors, right? Let us move to the next problem. So our next problem is, a person covers a certain distance at a certain speed, right? If he increases his speed by 20%, then it takes 20 minutes less to cover the same distance. So suppose let us assume that if the person is moving with a speed 100 kilometer per hour. So if we suppose a person is moving with the speed 100 kilometer per hour, automatically what is it? If a person covers a certain distance at a certain speed, if he increases his speed by 20%, so the same person have increases his speed by 20%, that is it is going to be 120. Let us suppose for the clarity it is B, right? Now if this is the, what is the ratio? This is the ratio of the speed. So what is it? 10 10. So 5 is to 6. So 5 is to 6 is the ratio of the speed. Then automatically if the ratio of the speed is 5 to 6, they are traveling the same distance, so the time is going to be in the ratio 6 is to 5. Now in the question it is given that if he increases his speed by 20%, then he take 20 minutes less to cover the same distance. So here he have increased the speed from 20%, right? So if he increases 20%, what he have taken? He have taken 20 minutes less. So 20 minutes less, here if you compare, what is the difference? 1 unit. So 1 unit is equal to what? 20 minutes. So 1 unit is equal to 20 minutes. So what do you want? Find the time taken by him initially to cover the distance at the original speed. What is his original speed? This is his original speed, right? So what is the time here he have taken? Have taken 6 units. Now we know what is the unit of 1. 1 is equal to 20 minutes. So automatically what is the time here is going to take 6 into 20 minutes. That is what? 120 minutes. So 120 minutes is our answer, right? Let's move to our next problem. Right, let us see our next problem. It is somewhat different problem. Please look over it. A man covers a certain distance in 40 minutes at a speed of 45 km per hour. So we have a certain distance D. He is going to cover in 40 minutes. So what is his speed? His speed is 45 km per hour. His speed is what? 45 km per hour. If he wants to cover the distance in 50 minutes, how much speed he should decrease? So what he is saying, suppose if you want to cover this particular distance in 50 minutes, so what speed he should decrease? So what is the speed he should decrease, right? So it is the question, right? So what I have given, this is the time and this is the speed, and we know the distance is constant. So we have given the time and speed and the distance is constant. So we know the time ratio also. So if we compare, the time ratio is what? 40 is to 50, that is 4 is to 5. So if the time ratio is 4 is to 5, then what is the ratio of the speed? It is 5 is to 4, right? So we know that this speed, what is this 5 is equal to what? 45 km per hour. It is what? 45 km per hour. So what is the 1 unit value? It is what? 9. 1 unit is equal to 9 km per hour, right? So 5 9 ja 45, right? So 1 unit is equal to what? 9 km per hour. So what is the speed here? Now for 50 minutes you should move with the fourth speed. So what is the speed here? That is 4 into 9. So what is 4 into 9? It is 38 km per hour, correct? Sorry, 36 km per hour. Sorry, 36 km per hour. So Now we have observed, we have got this value. What is this? This 36 kilometer per hour. So what we have asked in the question, how much he should reduce his speed. So from 45 you have to reduce to the 36. That is what? 45 minus 36 is what? 9 kilometer per hour. So you have to reduce his speed by 9 kilometer per hour. Right? So very interesting question. Let us move to the next question. Let us see the next problem. A car covers a certain distance in 3 1 by 3 hours. So a car is going to cover a certain distance in 3 1 by 3 hours. Right? If the speed is increased by 10 kilometer per hour, if the speed is increased by 10 kilometer per hour, right, then it will take 1 by 3 hours less to cover the same distance. So it is going to take 1 by 3 hours less. That is what? It is going to take 3 hours. If the speed is increased by, so if the speed is increased by 10 kilometer per hour, it is going to take 1 by 3 hours less. That is, if we minus 3 1 by 3 minus 1 by 3, we get what? 3 hours. So we have given the time and also the speed in one case. So we know the time case, right? So if we take this time ratio, it is what? 3 1 by 3 is to 3. 3 1 by 3 is to 3. So if we solve, it is 10 by 3 is to 3. So if we solve more, it is 10 is to 30. That is what? 10 is to 90. 3 moves here, 10 into 90. That is 1 is to 9. So if we solve this, we are going to get 10 is to 9. 10 is to 9. So what is this ratio? This is the time ratio. So what is the time ratio? Time ratio is 10 is to 9. If the time ratio is 10 is to 9, what is the ratio of the speed? It is 9 is to 10. What here we have given, it is going to take 3 hours when the speed is increased by 10 kilometer per hour. So if we see that the speed of A and B is increased by 1 unit from 9 to 10. So 1 unit is what is it? It is equivalent to 10 kilometer per hour. Right? Then in the question, what they have asked? They have asked the original speed of the car. So we know that 1 unit is 10 kilometer per hour. What is its original speed? It is 9. So automatically the answer is 9 into 10 kilometer per hour. It is equivalent to what? 90 kilometer per hour. This is our answer. Right? So up to here we have learned about the ratio method. We have solved different problems. So it is very easy to implement this ratio method in many of the problems. So you can easily implement it. Right? And I will also give some of, I will also give some of the practice problems. Please look over those problems and try to provide in the comment your answers. Right? So here we have solved many of the problems on the ratio method. We have solved the different kinds of the problems. And also I will be providing some of the practice problems. Please solve it and please provide in the comments. Thank you. So if we solve this, we are going to get 10 is to 9. 10 is to 9. So what is this ratio? This is the time ratio. So what is the time ratio? Time ratio is 10 is to 9. If the time ratio is 10 is to 9, what is the ratio of the speed? It is 9 is to 10. What here we have given, it is going to take 3 hours when the speed is increased by 10 kilometer per hour. So if we see that the speed of A and B is increased by 1 unit from 9 to 10. So 1 unit is what is it? It is equivalent to 10 kilometer per hour. Right? Then in the question, what they have asked? They have asked the original speed of the car. So we know that 1 unit is 10 kilometer per hour. What is its original speed? It is 9. So automatically the answer is 9 into 10 kilometer per hour. It is equivalent to what? 90 kilometer per hour. This is our answer, right? So up to here we have learned about the ratio method. We have solved different problems. So it is very easy to implement this ratio method in many of the problems, so you can easily implement it, right? And I will also give some of, I will also give some of the practice problems. Please look over those problems and try to provide in the comment your answers, right? So here we have solved many of the problems on the ratio method. We have solved the different kinds of the problems. Uh, and also I will be providing some of the practice problems. Please solve it and please provide in the comments. Thank you.